Yo, what's up? It's your boy Mr. AC, and what I got for you guys today is going over primarily, and we are on year number, so let's go ahead and get started. All right, let's go ahead and get started with the question of 2006. Now, problem very similar. You can see some trends as the years progress. They were asking for the particular solution, the equation of the line tangent, and now they're starting to ask slope fields a little bit more. So you can see kind of how they've advanced their questions, and you'll see as the years progress, just the level of difficulty continues to increase. Part A, on the axis provided, sketch a slope field for the given differential equation at the 8 points indicated. So 1, 2, 3, 4, 5, 6, 7, 8. Nothing else, nothing more, just these 8. Now, remember, what do we want to do first? Well, I kind of wrote it out here. You want to find your zero slope, and you're only going to get 0 when your y value is -1. 1 plus -1 is going to give me 0, 0 over x. It doesn't matter what the x value is, you're going to get 0. So that's why I went down below here and I put -1. I put a slope, a horizontal line to represent that slope of 0. So once we got the slope of 0, now we want to go through this in the most efficient manner, right? Well, again, personally for me, I always like to keep one variable constant at the minimum. Whether you want to go in rows, columns, is up to you, because there's more points on this bottom part right here. There's 4 points right here. That tells me that I want to at least have my y value be constant for all these values. Right here, my y value is 0. So let's go ahead and plug it up here. We're going to get 1 plus 0, right, divided by x. So this is essentially 1 over x. So now what I can do is I can plug in all these x values into here. If I plug in 1, I get 1 over 1. So this is 1. If I plug in 1 over 2, that's half. So this is going to be like more plateaued or more horizontal because the slope is getting closer to 0. If I plug in -1 into here, this is going to become -1. So a slope of -1. And if I plug in -2, 1 divided by -2 is -0.5. So again, my slope is going to be more horizontal because it's getting closer to 0, but it is negative. So see how I completed these 4 rows really efficiently by holding one of these variables constant, and then I can plug in the rest. Now what the only thing to do is plug in y equals 1. So I'm going to do the same thing. The y value is 1. If I plug it in, I'm going to get 2 over x. So all I need to do is just plug in my x value. 2 over 1 is 2, so that means the slope is going to be more steeper. If I plug in -1, it's -2, so my slope is going to be more steeper. There it is. And hopefully you can see that we were able to do this, I would say probably within, 2 minutes or so, being able to get 8 points done relatively quickly. And it's all about strategizing. What can I complete first? Well, 0 slopes. Always get those done because you'll get a point for that sometimes. Now you want to go ahead and get the rest of your slopes, and you do them in the manner that you think is most efficient. So let's go on. This is a short question, and we're going to go ahead and go on to part B. Okay, let's go ahead and get rolling on this one. We're going to find the particular solution, y equals f of x. Okay, that should be a big hint to you now. We got to go to the original function. So let's go ahead and separate the variables. What that means is we need to put the x's together and the y's together. So I'm going to multiply dx to both sides right here. That's going to cancel out this right here. And then I'm going to divide 1 plus y to both sides. So let me just put a divisor right here and write 1 plus y. Okay, so let me go ahead and show you what happened here. When I multiplied the dx to both sides, right, notice how we divided by the 1 plus y as well. When these cancel, a lot of times you get in the habit of just putting the x here. Well, you have to understand, let me go ahead and put a set of parentheses. When these two cancel, there is a placeholder of 1 in the numerator, right? The x is on the denominator. That's why it's 1 over x. And then the same idea here. The dy is on the numerator, but then we're dividing by the 1 plus y. So it has to go on the denominator, and then I put a 1 up above as a placeholder because there was no value here, right? If this was like 3 dy dx, well then this would become a 3 right here. But because we do not have a value, we do not need to put a value there. So now that we got this down right here, well, we're in business now to go ahead and take the antiderivative of this function. Now, how do I take the antiderivative of this? Well, the biggest thing is to keep in mind that there is no power on y, and this is like a little parenthesis right here that we have on this denominator. Now, when you have a function like this, that should scream to you that we're gonna use the property of ln natural logs, ln of x, right? So if I take the antiderivative of this, is going to be ln. Let me go ahead and write that out. Boom. Absolute value 1 plus y is equal to ln absolute value of x plus c. Right? That's what my function should look like. Now, I do want to make one note. Something that a lot of times we take for granted is when I do the antiderivative of this, I still need to take the derivative of this inside. Well, what's the derivative of y? It's 1. So I would be dividing by 1, but I don't need to show that. What's the derivative of x? It's 1. So I need to divide by 1. But again, because it's 1, I don't need to show that. In a future years, you're going to see where that won't be the case, and I'll show you when we get to that problem. Now, we need to find our particular solution. So let's go ahead, plug -1 in for the x and plug 1 for the y value right here. So we're going to get, so we plug in these values, we get ln absolute value of 2 equals ln absolute value of -1 plus c. Well, what is the absolute value of -1? That is 1. So this becomes ln of 1 plus c, ln of 2. What is ln of 1? ln of 1 is 0. That's kind of just like a popular just something that we know over time. Again, the question really, ln is the inverse of e. So really this question is asking you e to what power, let me put a, oh my gosh, hold on. E to what power, let me put a box instead, equals 1. Well, we know anything raised to 0 is 1. That's why the answer is 0. So this is gone and we're left with c there. And if you don't trust me, just to show off my calculator, we can type in ln of 1 and we get 0. So there it is. This is my c value. Let's go ahead and plug it back in. So we're going to get ln 1 plus y is equal to ln absolute value of x plus ln of 2. Now, to get rid of ln, what do? Well, to get rid of ln, we got to do the inverse operation, which is e. So we're going to raise both sides to the power of e. That's going to cancel out this here. Yes, technically, the e's would cancel with the ln's and it would involve some logarithmic properties. But again, for the sake of purposes of this video and the AP exam, we don't need to simplify all the way fully. So we're going to leave it as is, even though we do know we could theoretically simplify this a little bit further. That is totally fine. So here it is, boom, plus ln of 2. This should be parentheses, not absolute. There it is. And then all we need to do is subtract 1 to both sides, subtract 1 to both sides. So now that we've subtracted 1 to both sides, just for the sake of time and not rewriting this over and over again, let me just get rid of this real quick. We get y is equal to this function right here. And then that would be my final solution. Again, on the AP exam, you do not want to box anything, but I just wanted to show you this particular solution right here. So hopefully you guys enjoyed. Let's go ahead and move on to question number 2006B. Capiche?